All right, Algebra 2, Lesson 60, distinguishing between mutually exclusive and independent events. So we're going to talk about compound events. Compound events are when we're really dealing with more than one event or more than one type of event. When we're talking about, we're talking about things where we're working with probability, rolling a dice, finding a card in a deck, marble in a bag, right, spinning a spinner, those types of things. Events that have at least one outcome are inclusive events. Disjoint events are events that have no outcomes in common. So events that have at least one outcome in common are inclusive events. At least that's what I believe it should say. Yep. So let's go ahead and add that in here. In common are inclusive. So if I'm rolling 2 dice, there's at least one possible outcome where they might be the same thing. You can roll 2 dice and get a 1 and a 1. But if I roll a dice and flip a coin, are those inclusive or disjoint? Is flipping a coin and rolling a dice, are those ever going to get the same thing? They're disjoint, right? Are events that have no outcomes in common. They're not at all the same thing. To calculate the probability of one or the other of 2 inclusive events, we use this formula that you see down here. For 2 inclusive events, that means I can get the same thing. It's probability of event A plus the probability of event B minus the probability of event A and B. Okay? And we'll see these things worked out in mathematical terms here in a little bit. Okay, but just so you understand that P is probability and A is of that event, right? But before we go much further than that, I want to review with you just for a second, make sure that we understand probability. What is probability? If we don't know what probability is, it doesn't matter that we're talking about probability A and probability B and we're adding and subtracting probabilities if we don't know what probability is. What is it? No. All right, the answer given was the odds of getting something. Probability and odds are 2 totally separate things, right? What's the difference between probability and odds? Does anybody know? Okay, so let's start back at the beginning. Probability is a ratio. Odds is a ratio. Okay, they're both ratios. That's what they have in common. A ratio is where I have something over something else, right? What type of thing do I have in the numerator of probability? Number of Okay, so let me ask a question then. Maybe we don't know the right term. Let's say I want to know the probability of rolling a dice and getting a 1. The probability. How many sides does a dice have? 6 sides. How many 1s does it have? So what number is going to go on top in my probability? 1. All right, so you're right. The number that should go in the numerator of that probability is 1 because that is the number desired. And there's only 1. One isn't in the numerator because I'm looking for a 1. If I'd said I want to roll a dice and get a 2, the number in the numerator would still be what? 1, because there's only 1, 2 on a dice, on a die. Okay? But what's more important, because that same thing is true in odds, right? Number of desired goes on top in the numerator of either probability or odds. What's different is what goes on the bottom. Okay, so if I'm rolling a die and I want to roll a 2, what number goes on the bottom? Yes, right? 6, because it's desired over total. Right, so odds of rolling a 2 is 1 to 5, or 1 over 5, because 5 of them are not 2s. Okay, do we understand the difference between probability and odds now? If you don't, we won't even be starting off in the right neck of the woods. Okay, keep going here, if that'll go ahead anytime. Okay, Good. Since events that are mutually exclusive or disjoint have no outcomes in common, the probability of event A and the probability of event B is always going to be 0. They don't have anything in common. Therefore, probability of event A or B is probability of event A plus the probability of event B minus the probability of event A and B, which is going to equal, you're going to end up over here, probability of event A plus probability of event B minus 0, right? So you just wind up with probability of event A plus the probability of event B. It all sounds really complicated. For two mutually exclusive events, right, what they're saying is that it's just going to boil down to this. Okay, we take the probability of the first thing, rolling a die, take the probability of the second thing, spinning a spinner, right? They're mutually exclusive events, and add those fractions. So whenever I'm looking at mutually exclusive events and I'm looking at doing the math, I'm probably going to have to find a common denominator to get a final probability. Does that make sense? Okay? All right. Okay, independent events. All right, those are different. Independent is different from mutually exclusive. Independent events are where we talk about replacing a card in a deck. Okay, those are independent events. Okay, the formula below can be used to calculate the probability of independent events. Basically, I'm just taking the probability of event A and I'm multiplying it by the probability of event B. That's it. Okay, in independent events, I multiply probabilities for as many events as there are. Okay, so I'll continue to multiply. If they're the same event, let's say we're flipping a coin, we're going to end up taking it to an exponent. All right, so that's it for that. Let's look at some things here. Okay, William is on the school's archery team. The target has a center bullseye and 2 rings around the bullseye. The table gives the probability. Okay. Table gives the probability of each outcome. What is the probability that William will get the next arrow in the inner or outer ring? Inner here, or actually no, I think what they're referring to, they're excluding, yeah, because the bullseye, so we want here or here, right? Basically everything except the bullseye or a miss. What do I do? Add. Yeah. So we just want the inner and the outer ring, right? So 0.289 plus 0.423. What is that? Everybody's got calculators. We're adding up. 0.712. Okay, 0.712. We get B for an answer. Have we checked B for an answer? B is our answer. Okay, so what we have here are mutually exclusive events, right? Okay, so we're seeing the practicality there that we're taking. They're just showing me the probability. All I'm doing is adding those two things together. Okay, so when we see and, we're thinking add. Okay, let's come down a little bit further. Find the probability of rolling a 5 or an odd number on a number cube. Express your answer as a fraction in simplest form. All right, well, what's the probability of rolling a 5? Okay, 1/6. What's the probability of rolling an odd? 1/2, right? Because it's 3/6, but we can reduce it to 1/2. What do I do with those two things? Am I multiplying them? Okay, so you're saying I'm going to get 1/12. Is that right? Do I see that as an option? Okay. What we're saying, notice that here's the interesting thing about it. Okay. probability of rolling a 5. What type of number is 5? An odd. Okay, so are these mutually exclusive events?
Yeah.
No. 5 is an odd. Okay? So notice that it says or. Well, so my question is do you get to include 5 in the second set? Because it said or. Well, yeah, you would have to. So what do we do in mutually exclusive events? Do we multiply or we add? Okay, so we have 1/6 plus 1/2. What do I need to do to the second fraction? Multiply. I need a common denominator of 6, right? So I'm going to multiply by 3 over 3, correct? So I'm getting 1/6 plus 3/6. Okay, somebody go down to the bottom and check. Is 2/3 my answer? Okay, so we don't multiply. Is C the answer on 2? It says it's D. Oh, so it says it's 1/2. Okay, why is that? Because 5 is included in the odd numbers. Okay, so you wind up with really just simply 1/2. Because go back to our definitions of what we talked about at the very, very beginning. Okay, let's, oh, no, I don't think that's what I want. Okay, look at the definition of inclusive events. Events that have what? At least one outcome in common. They have, both events have what in common? 5. All right, so let's look at our inclusive events. Probability of event A plus the probability of event B. All right, that's where we got our 2/3 from, right? Or something like that. Was it 2/3? Minus the probability of event A and B. Okay, so we needed to subtract something. Does this make sense? All right, let's look at an inclusive event question. Let's see, example. Okay, you'll see some of these things with like example 1 in your book on page 427. You know, the spinner landing on a blue sector and the spinner landing on 4. Well, those are disjoint events. You look at B, the spinner landing on a blue sector and the spinner landing on 3. So there's a really good example with example 1 in your book because you have 3 is blue, right? And I'm looking at both those things. So the two sets intersect at B3, therefore the two events are inclusive. So we see some inclusive events being mentioned. I want to see if they have. Okay, you probably better yet is an example 2. Shows some of the math being done there. So what I want you to see is if you look at A on page 428, is what do they mean by A and B? So what you do is you've got, I'm trying to see how they do that there with the A and B. And how they got the 1/5, they got 2/10. Reduced on down to 1/5. So you're looking at, let's see, let's come back to our picture over here. Okay, so what we had is we had what, 1/6 plus 1/2 minus all of those things, right? So those things combined together. So let's look at that cube. We had 1, 2, 3, 4, 5. So we've got 1, 2, 3, 4, 5, 6, right? Okay, and we want odd and 5. Right? So we're back there at, we're back at 1/2. We're adding those things together. We have 2/3 minus 1/2, which gets you back to 1/6. So I'm still trying to figure out how they got just 1/2 using the math that they used. Let me pause on this for a second. All right, I can live with that. All right, so we're subtracting just the probability of what A and B have in common. The only thing that they have in common is the 5. So these two things cancel out, leaving you with the 1/2. I can live with that. I wish the book does a really terrible job of explaining that. All right, let's look at 3. Determine if the events are independent or dependent. You draw a 7 from a deck of cards without replacing it. Then you draw a 2 from the deck. What's the important word in that sentence? Without replacing. Okay? If I don't replace it, are those two events, the first draw and the second draw, are they independent from each other? You say they are independent. Is that what you said? Right. The second draw is dependent upon what I got from the first draw. Because I kept a card in my hand, it's now changed the probability of the second draw. Does that make sense? So anytime I do not replace something, it is dependent. If I replace it, it's independent. If you want to write that down somewhere, write it down, because it's going to be true every time. Okay? From here, let's look at least a question that's in your book that you might want to look at. Okay, because some of these, like these inclusive questions, can be a little tricky. So I'd like to do something from your book. Anything you see in there? Any from like the A through H portion? Your first two, A and B, are just looking at what type of inclusion you're working with. You don't really start to get to math until you're looking at 7, C through H. And really, E and F are just determining what kind of dependency they have, whether it's independent or dependent. So you got C, D, G, or H would be things that I might want to look at or ask about. Anything in there that trips your trigger? H? Okay, so H. We usually assume that the last one is going to be the hardest, right? Okay. The National Vital Statistics Report on Births in 2004 shows that approximately 48.8% of live births are females. Find the probability that women would give birth to 3 daughters, followed by a son, round to the 10,000th place. Okay, so we want 3 daughters, followed by a son, right? I'm just putting that information up so that I can follow that. Okay, and it says go back to example 5. Do you guys have something like this in example 5? Okay, it's a little bit different, but it does give you a probability percentage. There you're looking at 59.4%. Okay, survival rate of giant panda cubs born is 59.4. Find the probability of 4 giant panda cubs born consecutively into captivity. The first 2 will survive, and the last 2 will not. Round your answer to 10,000. So really not different. We have probability of event A, okay, which is 0.594. They just take that probability percentage and turn it into a decimal. And so we want to stick with that. Okay, so the probability of having a girl is 48.8%, right? All right, so we're going to convert that to a decimal. That would be what? 0.488. So 0.488, 0.488, 0.488. Okay, so there's only 2 options, right? I mean, I'm not making a social, political statement here. There's only 2 options biologically. Okay? That upsets you, I guess I apologize, but for the sake of mathematical probability, there's two options. Does that make sense? So with those two options, 100% are covered, correct? So if I want to know what the probability of having a sun is, I'm going to take 1, which represents 100%, minus 0.488. What do I get? .512. So the probability of having a sun is 51.2%, or 0.512, right? Okay, going back to example number 5, I think you'll see something similar where they subtract 1, or they subtract 0.594 from 1 to get the 0.406, because they're looking to have, let's see, 2 will survive, the last 2 will not. So basically all we're doing at this point is multiplying these 4 numbers. So we want 0.488 times 0.488 times 0.488 times 0.512. Or you could take 0.488 to the third times 0.512. Okay, 0.0595. 0.0595. Is that what you got? Okay, and that's the probability. Okay, we don't need to convert that to a percent. It says round your answer to the nearest 10,000. That's why we stopped at the last 5. Tens, hundreds, thousands, 10,000s. Okay, does that make sense? Okay. That gives you guys about 5 minutes to work. I'm going to go ahead and stop it here. If you guys have questions, let me know. Raise your hand.